Hi, students, and welcome to today's lesson. I'm Mr. Simpson. Today, we will explore the question, how are different forms of energy used in the dark rail system? Are you ready? Grab your pencil and your science journal, and let's get started. I have a video clip that I want to show you. But before we watch the video clip, let's create a chart. We can use this chart to record observations about energy after we watch the video clip. Let's give each of these columns a heading: mechanical energy, sound energy, light energy, and thermal energy. As we watch the video clip of a dark rail train, look for indicators of these types of energy. Try to identify at least one indicator of each form of energy. Let's watch the video clip.
District Station. This is the deadline. Final destination, Westmoreland Station. Next stop, St. Paul Station. Now arriving, Fort Plain Station. Doors will open to the left. For your safety, doors will open automatically.
What did you observe? Shout out your observations. Did you observe that the doors open and close and that the train moves? So did I. Let's add this information under mechanical energy. Also, a bell dings, announcements play, and music plays. These are all forms of sound energy. Did you observe the lights above the door flash or the ceiling light shine? I did. Where should we record these energy indicators on our chart? Yes, we will put them here under light energy. I also observed the vent where cool air moves into the train car. This is thermal energy. Let's write, air is cooled in the thermal energy column. In our previous lessons, we modeled how electrical energy travels in a circuit and is transformed into mechanical energy to move a light rail train. We should add electrical energy to the very top of our chart. We've learned that electrical energy can be transformed into mechanical energy. Electrical energy can also be transformed into sound energy, light energy, and thermal energy. The electrical energy in the train is transformed into other forms of energy to move the train and to power all the electric devices. In this lesson, we will use circuit models to explore energy transformations as we answer the question, how does a light rail system use different forms of energy? We will observe 3 stations: the buzzer station, motor station, and light bulb station. Each station will have 2 devices that can transform electrical energy into another form of energy. Do you remember the closed circuit we modeled? We know that a circuit is a system that includes a source of electrical energy and the complete path of an electrical current. Let's start by constructing a basic circuit using 1 battery, 1 device, and alligator clips. First, let's use the alligator clips to connect the battery to one of the buzzers. Did you hear the buzzer? It was loud. Next, let's connect the battery to one of the motors. The motor was spinning really fast. I could hear a noise too. Now let's see what happens when we connect the battery to the light bulb. I think the light bulb will light up. Do you agree? Hey, we were right. But wait, we have 2 buzzers, 2 motors, and 2 light bulbs at each station. We also have 2 batteries and battery holders at each station. How could we use the additional materials to change the circuit? Do you think we could use more than 1 battery? I think so. We could use more than 1 device. We can test different configurations of the circuit by adding or removing components from the circuit. But before we make changes to our setup, let's decide on our testing criteria. We will add or remove 1 battery or device to the previous circuit. We will arrange the batteries so that the positive end of 1 battery touches the negative end of the other. And we will connect only 1 alligator clip cord to each battery terminal. Let's revisit the buzzer station. Remember, When we completed a circuit with the buzzer, we observed evidence of sound energy. Here is a data table we can use to record information from our investigation. Remember the basic circuit we created? The basic circuit had these components: one battery and one buzzer. This basic circuit will be our control for the investigation, so we'll write control under effect on devices. Let's build 3 more circuits. How can we change this circuit? Remember, we can add or take away only one component at a time. Did you say we can add a buzzer? Great idea. Now our circuit components are 1 battery and 2 buzzers. Let's watch to see what happens. What is the effect on the devices from this change? I noticed that each buzzer is quieter. Did you notice that too? Let's record that observation. What is another change that we can make now? What if we add a battery? Now our circuit components are 2 batteries and 2 buzzers. Let's watch. What effect on the devices did you observe? I think the sound from each buzzer was the same as the basic circuit. Do you agree? We can record that here in our table. We need to make one more change. What should the change be? Did you say we could take away 1 buzzer? Let's do it. Now our circuit components are 2 batteries and 1 buzzer. Let's see what happens. What effect on the devices did you observe? The buzzer got louder, right? We can record that here in our table. Our next station is the motor station. Remember, when we completed a circuit with the motor, we observed evidence of mechanical energy. Just like in our first trial, we started with a basic circuit with 1 battery and 1 motor. Now we need to change the setup. What effect on the device do you notice? Shout out your answer. These are my observations. When the circuit contained 1 battery and 2 motors, the motors did not move as fast as in the basic circuit. When the circuit had 2 batteries and 2 motors, the motors moved about the same speed as they were in the basic circuit. And when the circuit had 2 batteries and 1 motor, the motor moved faster than in the basic circuit. Let's add these observations to a table. I created a chart for my observations. Now we have our last station, the light bulb station. Remember, when we completed a circuit with the light bulb, we observed evidence of light energy. Just like in our other trials, we started with a basic circuit with 1 battery and 1 bulb. Then we changed the setup. What effect on the device do you notice? Shout out your answer. These are my observations. When the circuit contained 1 battery and 2 bulbs, the bulbs were not as bright as they were in the basic circuit. When the circuit had 2 batteries and 2 bulbs, the bulbs were the same brightness as they were in the basic circuit. And when the circuit had 2 batteries and 1 bulb, the bulb was brighter than in the basic circuit. Let's add these observations to a table. Hey, I'm starting to notice a pattern with our data. Are you? What did you observe in circuits with 2 batteries and 1 device? Did you observe that when we use more batteries than devices in a circuit, the devices can transform more electrical energy into another form of energy? I did too. I observed that the buzzer was louder, the motor was faster, and the bulb was brighter in the circuits with 2 batteries and 1 device. What did you observe in circuits with 1 battery and 2 devices? When we use more devices than batteries in a circuit, each device transforms less energy, right? In the circuit with 1 battery and 2 buzzers, the buzzers were quieter. In the circuit with 1 battery and 2 motors, the motors were slower. And when we had 1 battery and 2 light bulbs, the bulbs were not as bright as in the control. What did you observe in circuits with 2 batteries and 2 devices? When there was 2 batteries and 2 devices in a circuit, each device transformed the same amount of energy as the control. So the amount of energy transformed by a device depends on the amount of electrical energy supplied to the circuit. Your task after this lesson will be to summarize the patterns you noticed in the device stations. Let's connect our new understanding of circuits to the dark rail system. Just like we saw electrical energy transformed into sound, motion, and light today, electrical energy from the substation is transformed into other forms of energy that power different devices on the train, such as the announcements, doors, and lights. Let's review your task for today. Summarize the patterns you noticed for each device station.